All right, so we're going to talk about the mole. And a mole is really just a counting word. Like if I told you I had a pair of socks, you'd know that I meant I had 2 socks. If I told you I had a dozen eggs, you'd know I meant 12. A mole is just like that, except instead of 2 or 12, we have 6.02 times 10 to the 23rd. So this bar is a mole of copper. So this tiny bar contains 6.02 times 10 to the 23rd atoms. And that is an enormous amount of atoms. So just to give you a little bit of perspective on that number, because it's so large that it's really hard for us to conceptually understand it. If you had a mole of marshmallows, like regular marshmallows, not mini, not jumbo, it would bury the continental United States to a depth of 650 miles. Okay, so just imagine how many marshmallows that would be. Okay, so this is a huge, huge, huge number. If you had a mole of elephants, like they couldn't even fit on the earth. So this is a massive number, and that's how many atoms are in this bar. So then imagine how small each atom must be. It's kind of mind-blowing. So what we're going to do is we are going to take the mass of 1 mole of copper, and we're going to figure out how that relates to what we see on the periodic table. All right, so I have zeroed my balance, and I'm going to take the mass of 1 mole of copper. So it comes out to 63.51. Now, if I look on the periodic table under copper, you might be able to see, you probably really can't see from here, but the mass of copper, 1 atom of copper, is 63.546. So it's really, really close to this. So the mass of 1 mole of a substance is the same as the mass in the periodic table. So since it says approximately 63.5 for copper, that's the mass of 1 mole of copper. So if I wanted to know the mass of 1 mole of carbon, for example, I could look on the periodic table, and the mass here, again, I know you can't really see it, but it's 12.01. So 1 mole of copper would have a mass of 12.01.